Hello, hello. Welcome everyone to another day of daily LeetCode live streams. Today is Tuesday, September 13th. Almost forgot the day. It's been a little bit of a slow day. You know, sometimes when you're working remotely, some days can go fast, some days can go slow, some days can be eventful, and other days can be uneventful. And today was definitely one of those uneventful days, but that's fine because it's life, and that's just sort of how it goes. So let me just go ahead and get all set up here. We're starting today at 255 questions. We're continuing on our journey to be able to do every single LeetCode question on the platform. Again, starting from the easiest all the way to the hardest, sorted by acceptance. Today, we're going to resume from where we left off yesterday, and I think I may have missed something here. No, yeah, algorithm's easy. Okay. So let's go on to this new question here. It is called maximum score after splitting a string. Let's see what this one has to offer. Back at it again. Yes, we are, Marvin. Have not missed a single day. There are going to be some slight changes now that you say back at it again. There is going to be I wouldn't say a hiccup. As far as you all know, the optics are the same. But starting in 27 days, I'm going to be on my paid time off, PTO, as you have it. And that means that I'm going to pretty much completely disconnect from everything in my life, because I think that's just the healthy thing to do, and it's fun to just, get away for a little bit. What I'm going to be doing is I'm going to be recording shorter videos, probably about half an hour in length. Maybe I'll just be doing, let's see, I might just do videos like the explore cards for those couple of days. That way I still put out some content for you all, and you guys don't miss out on anything. So expect that. I'll remind you all again the closer we get. That's going to happen in 27 days. But until then, we're going to continue on here. And yeah, let's just have some fun. All right. So given a string S of zeros and ones, return the maximum score after splitting the string into two non-empty substrings, left substring and right substring. The score after splitting a string is the number of zeros in the left substring plus the number of ones in the right substring. Okay, all the possible ways of splitting S into two non-empty substrings are, now when it says, okay, they can't be empty, cool. So 0, let's see, 1 plus 4 equals 5. And this is because what? Oh, is this two non-empty substrings? 1, and how do we get, is this just 1 plus, when they say 4, what do they mean by that? Left is 0. The right is 1, 1, 1, 0, 1. Wait, really? 1, 2, 3, 4, 5. When left is 0, 0, and right is 1, 1, 1, we get the maximum score of 2 plus 3. I don't understand this. Wait, given a string of zeros and ones, return the maximum score after, the score after splitting a string is the number of zeros in the left substring. Oh, plus the number of ones in the right substring. Okay, I was very confused about that. So 1 plus 3, okay. 2 plus 2, 3 plus 1. Okay, I see. I'm thinking of a way of doing this, and I feel like, let me see. I mean, at the end of the day, all the possible ways of splitting a string into two non-empty substrings. But the left here has 0 though, right? So wouldn't this just be 4? Oh, the number of zeros on the left, I see. I keep getting confused. So here we have 1 0 and 4 ones, 1 0 and 3 ones, 1 0 and 2 ones, 1 0 and, okay. Let's think about how to, yeah, we still have, I just saw your comment, Marvin. Enjoy it, bro. Yeah, I definitely am. I'm very excited to go. And I'll let you all know as we get closer. So let me think about how to do this. So if we start off with, this, I just let out a nasty yawn. I wonder if any of you all heard it. It's been a slow day. That's what happens on slow days. And I'm also a little bit sick, but nothing like too crazy. So like at any point that I'm increasing my left, like if I start here, for example, and then I guess what they're doing is they almost have like 2 pointers where they just continue expanding these. it's always going to be from the substring of 0 to I plus 1 from j to the end. How many zeros are in that substring plus however many zeros are in this right substring. So, I mean, you can almost sort of do this. We can do this in a brute force way, but that's, yeah, I think I have an idea because we're starting in the first one, right? So we need to count how many zeros there are in the beginning, right? And then we can also count how many ones there are from the j point all the way to the end. And then what we do, so let's say in the beginning, like I is 0, so that means I is going to be 1. And in j's substring, there are 1, 2, 3, 4 ones. So let's say that's 4. Now when we increase, let's see, when I increase j, if this one's also a 1, doesn't that mean that here, like, this would be a 3, right? I don't think it necessarily, well, I guess that would always go down. No, I'd have to be on the only way that increasing the j pointer would decrease the amount of ones would be if the thing that I'm currently on is a 1, which in this case I am, right? So if I increase the j, I'm losing a 1. And then I increase the I. And let's see here. This is not a 0, so we don't increase I. So it's some like interesting rules, but I'm gonna sort of like try and think of the algorithm like this. I think this could work because like I'm only having to count. Okay, let me do this. So let 0 count equals 0. Let 1 count equals also 0. We're gonna start, let's think about this. What's the algorithm that I want to do? I always want to start from where I currently am. Really, I just want to go, like at the end, this is gonna go all the way to here. So really, I want to say for let do I want to do I guess I could do for let I equals 0. I want I to be less than s dot length minus 1 I plus plus, right? Because as soon as this goes here, I want it to end because that's going to be the last time that I have my I and j. However, I haven't gotten my 1 count or my 0 count. So that's one thing I also need to do. My 0 count will be, let's see, here 0 count will be if s of 0, if s at 0 is equal to 0, I'll set it equal to a 1, else I'll set that equal to a 0. My 1 count, what I could do, forget this loop right here. For my 1 count, let's do 1 count. Let's actually have for let I equals to s dot length minus 1, I greater than or equal to 1, I minus minus, if s of I is equal to 1, 0 count plus or equals 1. So let me just take a pause here real quick and show you all like what I'm doing. Okay, like my 0 count, if I is going to start in the beginning and we're going to move this I pointer from left to right. The 0 count to start off with, we're going to initialize it with if index at 0 is a 0, we'll set it equal to 1, else it's just a 0. For the 1 count, I'm going to start from the end of the string, counting from index s dot length minus 1 all the way to 1, increasing as we see the ones. And that's how I'm going to get my 0 count. And now, really what I need to do is, let's see, 1 plus 4 is 5, so the 5, let's get like a max. Let's say max is equal to 0. What I want to do now is I'll bring back this for loop. Oh, didn't want to do that. I think we're on the right track here. That has a nice like to dislike ratio. We'll bring back the for loop, and now what I want to do is I can set, so let's think about this first iteration, right? We have I and we have j. So here, like right in the beginning, I should say max is equal to math.max of 0 counts, or I can say max of max or 0 counts plus 1 count, right? Because this will be 1 0 plus 4 1s. And I just realized that this is a string, so I need to set this equal to be a string also. And this is also a string, so I need to set that to be equal to a string. And then what do we do on the next side? Now we increase I, right? So when I'm about to increase I, let's see, what can we do? I also just realized something though. I might not need to initialize 0 count here, but I definitely need to have my 1 count. Okay, so let's forget 0 count and let's set it equal to 0. Okay, I think we're gonna do this one even better. Forget 0 count. We do need our 1 count. Here we can say, let's see, if s of I is equal to 0, then 0 count plus or equals 1, right? And then we get our math.max of the 0 count, which is 1 plus 4. That's going to give us 5. And now, what do we do on the next one? If s of I plus 1 is equal to 1, that means that we decrease 1 count. Okay, so hear me out on this one. I know it may seem like a little bit weird how I'm doing things here, but I think we have something good going for us here. So what is it that I did, right? We're starting at this first index here, because if you look at the way this, like the left side is growing and the right side is decreasing, really it's the substring from 0 to I plus 1 and then from j to the end. So I set 0 count to be 0 and 1 count to be 0. How am I getting my 1 count? Well, I'm considering all the numbers from s.length minus 1 all the way up until index 1. And anytime I see a 1, my 1 count, so it's good that we're going through this, 1 count I'm going to increase by 1. And my 0 count, I'm actually going to declare down here. And the reason I'm doing that is I think there's like a best practice called like proximity or recency, maybe not recency, but the place in which you declare your variables. I like to declare them as close to where I use them because it makes finding the references to these variables a lot easier. Sometimes you have variables that you're declaring or rather you have variables that you declare at the top of your function or at the top of a class or something, but you don't use them until tens or even hundreds of lines down. I've seen that all the time, so I try to declare them where they're necessary, where I see them, where I see they fit the best. So you have max equals 0 and 0 count equals 0. Excuse me. So we have for let I equals 0, I less than s.length minus 1, I plus plus. Here we have if s of I, and let me remove all this stuff now, just like I was saying. I'm going to move it to the bottom so our example comes a little clearer. Right? We have I equals 0 and let's say j. Really, this should be 1. This should be 0 count, and this should be 1 count is 4. So if s of I is equal to 0, which it is, then I'm going to increase my 0 count by 1. Okay, now I'm going to say the max of 0 count plus 1 count, that's 1 plus 4. Okay, now check this out. Now if s of I plus 1, which is this one, if that's a 1, I'm going to decrease 1 because I is going to come to the next thing now. Right? So j needs to be subtracted by 1 because we just left a 1. It's no longer included in its substring. Right? Now here we get to the next piece. S of I is not 0, so we don't increase 0. We take the max, which is 5, or we do the 0, which is currently just 1, plus the 1 count, which is 3, and that's 4. Right? And we go to the next piece. Again, we subtract 1 from 1 count. We come over here, do the same thing again. Now we come over here. We don't do anything with I, right? We also don't do anything with 1 count because we're not losing a 1, or are we? We actually are. We actually are using a 1. I think that if... are we losing a 1 in that case? Let's go over some other ones, like 0, 0, 1, 1, 1. Maybe this will change things. So my 0 count is 0. My 1 count is 3. Okay, so for let s of I equals 0, so we have a 0 count of 1. 1 plus 3, that's 4. Okay. S of I plus 1 is 1. We do not decrease the 1 count, right? We still have 3 1s in J substring. But 0 count went up by 3. Now we do 2 plus 3 is 5. Okay. S I plus 1 equals 1. So we do decrease I count, right? Because it makes sense. Now J only has 2. Okay, that's fine. So I think that could actually work. Let's go ahead and try that out. We'll remove all this. We're left with this. And at the end, we'll return max. Let's see what this gives us here. I'm just going to go ahead and run it for all their different test cases. 4, 3, and 3, 5, 5, and 3. Okay. Let me see if I may have maybe initialized one of these. So for let I equals s dot length minus 1, I greater than or equal to 1, I minus minus. If s of I is equal to 1, 1 count plus or equals 1. Okay, max is 0. 0 count is 0. If s of I equals 0, 0 count plus or equals 1. Max equals math.max of max, or 0 count plus 1 count. And here we're getting 4. Now, why would that be? Oh, I don't want to copy this whole thing. I just want to copy the input here. For this first one, so if I do 1 count and I have my I be s dot length minus 1, I is greater than or equal to 1, I minus minus. If s of I is equal to 1, which it is, 1 count plus or equals 1, then we go downwards. We don't add anything. This is 2, this is 3, this is 4. Okay. Now we say, so let's say 1 count is equal to 4, 0 count is 0. We have s of I is equal to 0 now, that's fine. If s of I is equal to 0, 0 count plus or equals 1. Max is math.max of max, or 0 count plus 1 count. Oh, okay, I see. Did it not also make this a string? Very good reason to do quick debugging with your code before you try and submit it or anything. So let's see, 5, 5, and 3, 5, 5, and 3. So let's see how this goes for us. All right, starting off nice and strong, 46.97. I like this question a lot. I feel like this is a little bit different than like the questions I've normally done. I want to submit it again and see if we can get a higher trend on these percentages here. Feeling good. I'm glad that we're starting off strong. Like I said, sometimes the streams, wow, that's crazy. I'm literally talking about how strong we're starting off, and I literally land on a 100% time complexity. This is like the second or third time maybe out of all these videos that I've done that we're here sitting at 100%. So I wish there was a way that I can like, well, I'm certain there's a way that I can have like something come up on stream when I hit 100%, like some sound or something. Like that'd be fun to have. But I know Marvin's probably still around. So and honestly, you've always been here, so you've probably seen me getting 100% in the past. So now that I know that this for sure could be a great solution, let's think about this, right? Time and space complexity. So the time complexity here, I'm going through essentially n here, right? I mean, it's just off by 1, but really it's trending toward linear. And then here we're also going n. So n plus n trends to O of n, and space complexity is constant. So linear with a constant space complexity. I love it. I think this is a great solution. Let's see what discussions have to say. Java one-liner. This can be done in a single pass as below. I guess, yeah, my thing is to know total wants the result before returning. Zeros plus plus, else ones ones. If max equals zeros minus ones max, return max plus ones. Result equals max of zeros on left plus ones on right, max of zeros on left plus total ones minus ones on left, max of zeros on left minus ones on left plus total ones, as total ones is constant. Nice. I feel like a zombie. Genius. Nice solution. Awesome. Yeah, I'm pretty happy with the way that we covered it up. I mean, we're having to still count the number of ones. I'm not really too concerned about making it, you know, I think that doing it in one pass is cool, But, you know, we talked about this, and I think that's like the point of these streams. You know, you heard me approach it. We talked about it. We took our time with it, and we came up with something good, 100%. So I'm very happy about that. So I'm going to like this question. I'm definitely going to want to add it to my site after. I think it's really nice. So let's keep going here. So, ooh, Ransom Note. What a great question. I have been asked this question many times. If I think it's the right one, if I think it's the one that I'm thinking of, I've been asked this question many times in interviews. So definitely let's approach it. Let's think about it. Let me see if I even remember how to do it. But I know it's a good question, so you should learn how to do it if you don't already. I'm gonna have a sip of water. So drink your water. If you have some water, drink it. If you don't have water, go get some and drink some water. Stay hydrated, folks. Okay, so given two strings, ransom note and magazine, return true if ransom note can be constructed by using the letters from magazine and false otherwise. So I think what we need to do, ransom note can be constructed using the letters from magazine. Ransom note and magazine consists of lowercase English letters. I think this is a classic like frequency question. And because we have lowercase letters, we can create a frequency using an array of size 26, and we'll fill that up with 0. And we want to use the letters from magazine, which means that, let's see, for const c of magazine, we'll get our index c.carcode at 0 minus 97. Excuse me. And then in our frequency at that index, we'll increase it by 1, right? So now we have the frequency of all the different characters inside of our magazine. Then I think all we need to do is we need to go through our ransom note. For const c of ransom note, we're going to try and use characters. If at any moment we don't have a character to use, then we return false, right? So let's think about this. We want to use it, and then we want to see if it's less than 0. Or we first want to check it. So I think it should be, I think we can say if frequency of C, let's see, if I use it first and then, it wouldn't make sense for me to use it and then check it. I should check it and then decrease it. So frequency minus of C is less than 0, then we return false. Else return true. And what is this saying? So this is a postfix operator, which means that the expression frequency C less than 0 will be checked first, and then the operation will be done, which means that the frequency of this character at this index will be decreased. And I just realized that we need to get the index, right? Frequency of the index minus 0. So this means that we're first checking to see, do we have a letter, right? If it's already less than 0, now if it's also equal to 0, so it should be if it's less than or equal to 0, return false, because I can't take from nothing. So if we have like an A, right, or let's say in this example, ransom note is A, magazine is B, right? So now we're looking through ransom note, we're looking in the A position, frequency of index of A is less than or equal to 0, so we return false, right? Here, ransom note AA and magazine is B. We have one A, but then we get to the next A, and that's 0. Here, let's see, ransom note and magazine, we have an A, we go down to 1, or rather we have 2 A's. So we use one A, that's 1. We have 1 left, we use another A. So let's see if this goes through. False, false, and true, false, false, and true. Let's submit this. 58.08. So this is a very, very nice question. And there's a couple things that I want to mention here. So we know 2 things to take note of, and I'll particularly, well, rather not particularly, maybe that's not the right word choice, but I'm going to hint, actually not even hint, something that I asked during hitting all greens today. I know it's like we're doing really good today. I'd like to think it's just like, I hope it's not that we're just like on a good streak and we're just getting lucky. I also want to think that we are just landing, like our experience has gotten us to where we are today, right? We started from literally question 0 on July 16th, and we're over 250 questions. So we know a little bit now, right? So I'm thinking that because of the approach that we're taking, the questions we're doing, our knowledge now, we're doing better. So I'll say two things about this one. Make sure in an interview setting that you ask, if you first ask the question, are we dealing with only lowercase letters? Are we dealing with any amount of symbols that are not just lowercase letters, maybe also like numbers and whatnot? That can help you formulate the data structure to use. And it also gives you brownie points for asking good questions, right? Because if they say only lowercase letters, then maybe you use this nice, fixed size array that keeps the space complexity constant. Or if they tell you, oh, we're using, well, even still, if we're using like any, let's say, ASCII character, you can make a larger array of size 128, right? So on and so forth. You can use that knowledge to your advantage. And the second thing is, in one of the interviews I had, I decided to make, I think it was, I had asked if we can make it case insensitive, and they said, yeah, that's fine. So I made each of the inputs too lower to normalize them, and I made a copy of them as to not modify the inputs. So things like this are things that can bode well for you in an interview, asking the right questions, putting, like, almost controlling the conversation to give yourself an opportunity to show off something that may otherwise not be a common thing, if that makes any sense. At least in this case, this person was happy that I decided to, clone the input. Instead of modifying Ransom Note and to lowering it, I created a new string called like to lower Ransom Note and set that equal to the lowercase version of Ransom Note, so on and so forth. So control the interview and give yourself opportunities to showcase the skills that you can showcase. All right, 67.09. I'm really happy with this. We go through both magazine and Ransom Note. So because of that, it'll be like I'll say an M plus R Ransom Note, or M plus R time complexity, where M is the length of magazine and R is the length of Ransom Note. And then also constant space complexity. Marvin asks, so ask for the test cases first. It's not really about asking test cases. So, well, I guess, you might hear them being called like clarifying questions. So it's things like you ask, oh, do I have to consider empty strings? Do I have to consider null inputs? Can I assume that my input strings are all lowercase? Do I have to worry about case sensitivity? Does my inputs, like, what's the range of inputs that, I can have? Do I only have to consider lowercase or lowercase and uppercase, or also all alphanumeric characters, so on and so forth? Yeah, exactly. Like, ask your clarifying questions ahead of time, and that's going to help you decide on your data structure, because here these constraints are kind of the clarifying questions for it. Like, they're kind of giving us the hint, right? But if we're not going to have this in an interview, so it's good to ask, hey, by the way, are Ransom Note and magazine only lowercase letters? And if they say yeah, then I would talk about, okay, I'm going to use an array of size 26 because I only have to worry about lowercase letters. Instead of having to create like an object literal to keep track of my frequency, I can just create this fixed size array, which does better in memory because it's a contiguous block of memory that you're asking for, instead of something like a heap, or rather an object literal that's stored on the heap. It's dynamic, but being able to ask for this once and it always being the same is better for your performance. All right, cool. Let's get to the next thing here. Rearrange characters to make target string. All right, so you're given two zero-index strings, S and target. You can take some letters from S and rearrange them to form new strings. Return the maximum number of copies of target that can be formed by taking letters from S and rearranging them. I'm going to have another sip of water, guys. Okay, so I don't think it wants us to find, okay, I'm just going to do something just straight up here. Like, I think this might be, I haven't even read the rest of the description. I just want to see if this is like a frequency question. So I'm just going to start from the first character. So we have one I, I'm going to delete this. We have one L, we have one O, we have one V, we have one E, we have one C, we have two O's, we have one D, we have two I's, We have 1n. We have 1g. We have another O. We have another N. We have another L. We have 2 E's. So that's going to give us 3 E's in total, right? We have a T. And then we have a C. We have an O. We have a D. And we have another E. So I think, let me see, how many of these codes can we make? So like, I think what they want, yeah, I don't think it's like, I think we just take the frequency, let me see, and this also consists of lowercase English letters. So I think we can take the frequency of, all the characters here, and then the amount of these that we can create is bounded by the lowest of the frequencies. Do they give you the return type? Well, it depends on how they, sometimes I've had interviews that are literally like, I don't know, write a function to do this, right? Where they tell me what this is. It's like just a blank slate, right? I've had interviews like this. I've also had interviews like this on LeetCode where it says here return is of number. So you just have to kind of go with that and know. Obviously, if they give you the return type, you might still be able to get some clarifying questions on that. If not, then yeah, I would definitely confirm the return type with them. You can, and I wouldn't even say, like, let's say you really think you know what the return type should be. I would always don't make it seem like you want to assume anything. If anything, I feel like the best thing would be, like, I wouldn't, for example, say, oh, I assume that we can just do this, because they might think that maybe you're being a little bit presumptuous in thinking that. I think it's better to say, oh, you know, I'm thinking that I can return this for maybe these inputs, but if in the future I wanted to do X, Y, Z, maybe this other data structure or this other return type might be better if I want to, you know, scale it or something, or make it more flexible or something like this. Anyway, I think what I'm going to do here, I'm going to take the frequency, again, same thing we did, new array of 26 with 0. And we're going to take the frequency of S. So for const C of S, literally the same thing we did in the previous question. Car code at 0 minus 97. Then here we'll say frequency of index plus or equals 1. And I think really all we need to do, let me see, target. Yeah, I think we can say let min equal infinity, and we'll do for const C of S. I'm literally just going to copy this, and then I'll say min equals math.min of frequency of index or min. I feel like that's what they want. 1 and 2, really? Okay. New frequency for const C of S. Frequency of index plus or equals 1. Did we not have, let me see, let me go all the way back. That's why I should never delete these things like prematurely. Oh no, did I just lose all my code? That sucks. Oh, it's all right. We didn't write too much. Let's see, C is 2, O is 4, D is 2, and E is 4. So it should just be the minimum of those. Const frequency, new array. It says that S and target consist of lowercase English letters. So const index, C.carcode at 0, minus 97. We're adding 1. And we're saying for const C, oh, you know what? I think I did, maybe I didn't do target. So let's do const index. Let min equal to infinity. Here we'll say min equals math.min of min or frequency of index. Remove all that. Return min. Maybe I think I went through C. That's why. I think I went through S instead of target. 2 and 2. There you go. Using all the example test cases. 2, 1, and 5. Really? AAAA. We can make one copy of AAAA by taking letters at indices 0, 3, 6, 9, and 12. So we return 1. Oh, but it's not so much like... Yeah, see, that's a good edge case. Ooh-wee. Wow. These are tricky ones to sometimes think of the edge cases like this. So here we literally have 5. We have 1, 2, 3, 4, 5. We have 5 A's in our string, but our target is also 5. So we shouldn't take... Let's think about this. Do I need to also take the frequency of characters in... Okay, so what if I said in code, or not code, was that code? Yeah, target is code. In code, I need 1C. And how many of these do I have? I have 1 and I have 2. So I need 1C and I have 2. So maybe I could make up to 2. For O, I need at least 1 O. And I have 2 O's. Okay, D and then E. But E, I can't make more. Yeah, no, it has to be bounded by the last one. Now, I was almost thinking that it needs to be the minimum of the frequency, and that's okay. You see, this is a great edge case, because what happens if it's like all the same character? I have 5 A's, and my target also has 5 A's. So it's like, for every character, how many do I need and how many do I have? I think it's the minimum of that. I think that's maybe what the answer is. Instead of just saying the minimum, it's like I might need the frequency of all these. Because I have how many C's? I have 1 C. I love coding on LeetCode. I have 2 C's and I need 1. So if I only need 1 and I have 2, I can say, well, I can make up to 2. I can make the maximum. Right? And I have code. I have 1. I love coding on LeetCode. I have 4 O's. I only need 1. But I'm still bounded by the smallest one. So I think it's almost like here I need 5 and I have 5. So maybe we just do 1. So do we just do the minimum of the frequency and input divided? Is it something like maybe min is equal to math.floor of frequency of index divided by target frequency of index? I'm thinking maybe that, because here I have, or like here I have 1, 2 A's and I need 1. So I could make up to 1. Okay, so I say 2 divided by 1, that's 2. I have 2 B's. I only need 1, so I can make 2 B's. I have 1 C, and I only have, yeah, maybe it's this one. So let's actually take, let's say S, instead of frequency here, we're going to call this S frequency. And then I'll create a new one. I'll say const target frequency. Target frequency is this. And now let's actually let's do this. I'm going to create a function up here. I'm going to call it generate frequency or get frequency. And we're literally just going to do this. We're going to say const frequency equals new array of 26.fill0. And here we'll also take a word, right? We'll just remove the parentheses. Here we can say for const c of word, we'll do the index and we'll say frequency of index plus or equals 1. We'll return frequency. And then here I can say get frequency is get frequency of s. Const target frequency equals get frequency of target. And then at the end, what we can do is, so we say how many of one do we have? Yeah, so I think we still want to go through target. So let me remove this. Let me remove this. Hey, Hamza Mahid, thanks for doing these, man. Really helpful. Yeah, thank you so much for joining. It's always a pleasure to see some new faces around here. I certainly love doing these streams. I learn a lot myself. I'm not sure where you found me. I know I've been trying to promote a little bit around the internet, not too much, but wherever you come from, really great to see you here. This is more like a journey for myself that I'm just streaming mainly for fun, and I'm also learning a lot, and I hope that you can also take a lot of value from it. So really appreciate you being here. All right, so I feel like I still want to, wait, do I even need this? I don't need this anymore either, right? So we can say min, yes, I think I still want this. I want to go through target. I'll get my index. Here I can say math.min of, let me see. I have 1. So 2 divided by 1, we can say something like math.floor of s frequency of index divided by target frequency of index. Right, because now what will happen is when we get over here, let's go through like the whole thing again, right? We have how many C's? We have 1 C, we have 2 C's. So we have 2 available, we only need 1. So we do 2 divided by 1, that's 1. We have 1 O, 2 O's, 3 O's, 4 O's. We have 4 O's available. We only need 1. So that's 4 divided by 1, which is 4, but it's not, the minimum 2 is still going to win. Then we get to D, I love coding 1 on LeetCode 2. 2 divided by 1 is 2. And then E, I love coding on LeetCode. That's like what, another 4? So it's still going to be 2. Here, A, B, C, we have 2 A's. We only need 1. Okay, we have 2 B's, we only need 1, so that's another 2. Here we only have 1 C. Okay, and then A, we have 5 A's, and we have 5 A's, so 5 divided by 5 is 1. So let's see if this gives us the answer. Oh, of course, don't want this lingering math.min. Man, I just got incredibly hungry. 2, 1, and 1. Okay, so now our test cases pass. Let's see if it works for all of it. I'm telling you guys, we are on a roll today. I'm like, I really hope, like sometimes I feel this way and I'm like, man, I really hope that we have like people watching. Obviously, these streams are always available on my YouTube, but there's not I guess I can make like best hits YouTube playlist where it's like we go through questions where things are just like going well. But I think this is a combination of practice, the practice that we've attained since July 16th, and also a very important thing that I can't stress this out enough is the same way that I'm talking about these on my stream, I'm talking out loud, I'm telling you my thoughts. This is exactly the sort of thing that you should be doing with your interviewer, because that way they can give you hints, they can walk you through the thought process, they can see where your head's at, and you can see that we had an error. And then we rethought the whole thing, and now we arrived at the answer. So let me go ahead and submit this again. And it's that slow process in the beginning that I think helps us get there, right? It's us talking about it, building on things iteratively. I'm not just like, unless I know a question very well, you might see me do this on stream, like I just start coding. But what I'm really trying to focus on is taking my time with the design and my approach. That way I try and catch my errors as I'm talking about it. So time and space complexity. So for each one of these, right, we're going through sea of words, so this will be like S plus T, O of S plus T, where S is length of S and T is length of target. And then again, so it's like O of S plus T, which really just boils down to O of S plus T. And the time complexity here is, even though we're going through this twice, these are both constant space operations. So the space that we're using here is constant. So it's going to be an O of S plus T time complex algorithm with a constant space time, or a constant space algorithm. So yeah, I also really like this question. I can't remember if I liked the previous one. I think the previous one was good too. Rearrange characters. No, wait, was that the one? Maximum score after splitting a string. Ransom Note. Did I like this one? I must have. I feel like that one. Oh, wow, I didn't. That's funny, because Ransom Note is like, that's a classic question. All right, let's see. We have a little over 10 minutes left, so let's see if we can get to another one here, guys. Range sum query immutable. So given an integer array nums, handle multiple queries on the following type. Calculate the sum of the elements of nums between indices left and right inclusive, where left less than or equal to right. And what do they mean when they say immutable? Immutable. Okay. So why does it say immutable? Like, I'm trying to think where the immutability comes from. So this takes advantage of I guess, I don't know if it's really called a data structure, but it's called a prefix sum, where you calculate the sum of all the digits. Like, how do I say this? You calculate the sum of all the digits as you're iterating over an array, so that you can at any point query any index and you'll be given the sum. What do I mean by that? Okay, so this nums, right? We have nums that's going to be, let's say, this array like -2, 0, 3, -5, 2, -1. What we can do is we can calculate, right? We can say, let's say this dot prefix sum. I'm trying to think about a nice way of doing this. Maybe we'll do this dot prefix sum equal to an empty array. And then we'll say here we can do for const n of nums. Let's see, maybe I also want like a previous. So let previous equals 0. Here I'll say this dot prefix sum equals n plus previous, or we should actually do this dot prefix sum dot push is equal to n plus previous, and previous equals n plus previous. So let's say in the beginning here we have -2, 0. This is like the input array, and let's say previous sum is down here. We're building it up. We start at n. We do n is -2 plus 0. That's just -2. And now previous sum is just -2 plus previous. So that becomes -2. Now we get to the next one. We do 0 plus -2. That's going to be another -2. And we'll do 0 plus -2. So previous is still -2. Then we'll get to 3. 3 plus -2 is 1. Let me make this a little bit nicer here. And now n plus previous is going to be -2 plus, let's see, or rather 3 plus previous, 3 plus -2, which is 1. I guess previous really can just be the thing that we just did. Yeah, I guess n plus previous is still fine though. So we're just going to continue building up our array like that. And then that's it. We've constructed our prefix sum based on that initial sum. And I'm wondering if there's like a nicer way I could initialize this previous sum to be nums of 0. And then I can say for let I equals 0, or maybe I1. Let me think about this. I less than nums dot length. I plus plus. I can say this dot prefix sum dot push nums of I plus this dot prefix sum at this dot prefix, or this dot prefix sum I minus 1. And that should be the same thing, right? Because we're adding the current thing at nums of I, and we're adding it to the previous thing, which is this dot prefix sum at I minus 1, and then we're continuing to push the prefix sum. So now what this gives us is a nice way to come up with this query, right? We're just taking our prefix sum, and let me print this out just so we have a reference to it. So this is our input, or rather, let's just get our array here, right? And I think it said inclusive, right? So I'm gonna leave this up here, and I'm gonna leave it commented so we can see it. So it says left and right. So if we want, excuse me, if we want inclusive from 0 to 2, let's see, our output is just going to be like if the index on the left is 0, then we just return the index on the right. So the index on the right is 1, and that's what the first answer is, 1. Here, let's consider 2 and 5 later, but again, if this is 0 and 5, we just return the thing at 5, which is -3. Now if it's 2 and 5, right, what we want to do is I think we can just do the 5, like 3 minus the thing at 2. So -3 minus 1, that's not -1. So it might also be minus the thing to the left. So -3 minus -2. Yeah, so I think here we can say, and I wonder if we can always do, yeah, here we can say let sum. It's always going to be the right thing. Now, well, it's not always going to be the right thing, right? I can't assume it's always going to be the right thing, because indices left and right inclusive. So let's come up with different edge cases here. One of them is that we have the left bound, which is like 0. We have 0, and maybe we have the right bound, or we can have something that's not the right bound and the right bound, or we have the left bound and not the left bound, or we have something in between like 2 and 3. Okay, so if it's 0 and 5, we just return this dot prefix sum at position right, 0, 1, 2, 3, 4, 5, -3. If it's 1 and 5, or in this case, if it's 2, let's do 2 and 5 because that's the example, we're still going to return this, like -3, but now we're going to do plus whatever is right to the left of -2, whatever's to the left of 2, which is 1. So we're going to do this dot prefix sum right minus this dot prefix sum left minus 1, right? Because that will give us a -3 minus -2. So now we add -3 plus, or -3 plus 2, and that's going to give us -1, which is the answer they're looking for. Now if we have 0 and 4, well, I guess that's the same thing. We just return, actually no, yeah, we can just return 4 here. So that's good. And I guess here it's going to be the same thing, right? So, okay, so I just wanted to like go over those examples. So it's always going to be right. And then if the left one's not 0, we also do this. So I think we can say let sum equals this dot prefix sum minus right. If left is not equal to 0, then sum minus equals this dot prefix left minus 1, return sum. Let's go over this and see what this does for us. So null, 1, -1, and -3. Let's run it by all our test cases. They only give us 1 here. Of course, I ran it too fast. Submit it. 97.22. I hope I did this in an immutable way. I'm not sure where the immutable part comes from, but the important thing here is that we're handling multiple queries of the following type where we're calculating the sum of the elements of nums. So a prefix sum is just that exactly. we create this array that keeps track of sums. Like at any index in our prefix sum is the sum of all numbers to the left of that index. And that's exactly what we want. So now we can query for this prefix sum, and it can be done very fast since it's constant time access for this array if we know what the index is, which is what we're given here, right? So if we think about the time complexity, here, like the creation of this is going to be O of n, right? Every single time. And I think we only create this once and then do each of our queries, which is a constant time operation. So I think that's pretty cool. And space here will also be linear since we're creating a new array based on the size of nums. So I think that leaves us on a very good spot. I mean, we went through 4 questions today. That's usually not what we're able to do, but everything went very well today. So I'm very happy about that. If you like what you saw, and if this is your first time here, I want to welcome you to the channel. If you like what you saw, you can always visit my YouTube channel here. If you're watching me on Twitch right now, my YouTube channel is where I have all my content. I have all of my LeetCode streams that I've done since July 16th. I have them all in a collection called LeetCode Live Easy Collection. I also have a playlist of Explore cards that I am beginning to do, where I go through questions related to the Explore cards on LeetCode. I also have weekly roundups that I do on every Sunday at the end of every week. And then I finally have this other section here called With Vanilla, where I experiment with some front-end projects strictly using vanilla JavaScript. So if you like LeetCode, you like listening to me talk as if, this is like a podcast of sorts, then you're in the right place. I recommend that you stick around, subscribe to me on YouTube, follow me on Twitch, ring that notification bell. It really helps me out. And I hope to see you all again tomorrow at the same time, 5 p.m. Eastern, for another episode of your daily dose of LeetCode and JavaScript. Have a great rest of your